All right, friends. Today we will finish our Quadratics CCA prep / review. Does this cover every little thing you need to know about quadratics? No, but it covers the big ideas so that you know what, yeah, it does pretty well, so that you can go back and do your studying to get ready for this thing. Sketch each parabola by first writing in the form y equals x, ax minus h squared plus k. Ooh, little note under that. What's this form called? It's got all the fancy words in there. That's vertex form. How do I get a quadratic from this form over to vertex form? Yeah, the square thing. Yeah, the square thing, right? So that procedure becomes very important. It wasn't just me torturing you. It's the way to get a quadratic into the nicest form for graphing. I think this is the nicest form for graphing. I'm not saying it's the nicest procedure. No. I'm not saying that. I'm saying once we're in vertex form, we'll graph very quickly and easily. So under here, note to you, this is me helping you out on your CCA. Complete the square. And here again, I'll take another shot at saying the words that make you go, oh, that's why it's called complete the square. Maybe you don't even know why it's called complete the square. Okay, the complete the square procedure involves, first step, common factor anything that's on the x squared. And there is something on the x squared here. There's a negative. So we take that negative off there. But I'm not going to take it off the negative 13. The negative 13 is not the right magic number anyways. It almost never is. So I just move it out of the way. I'm not ignoring it from a common factor standpoint. I'm setting it aside and going, get out of the way while I complete the square. After I've done my common factoring, then it's magic number time. And how do we get that magic number? I hope that yesterday, me poking into your brain, rattled around all day, now you're like, I know how to get the magic number. How do you get the magic number? B over 2 squared. And usually, I don't know, grade 10 math students for decades, somewhere on their page, I don't know why. We could do it right over here, but you usually see something like this over here on the page somewhere. We'll hear on the side, okay, what is it? And this is like a thinking spot. My teachers did it. They taught it to me. I taught it to you. It's just carried through the generations. But you can't. You can go over here and do it. There's no reason for me to do it off to the right here. It's sort of a little trigger here, yeah? And the b here is 10. So I'm going 10 divided by 2 and then squared. What's 10 divided by 2? 5 squared is 25. Oh, we're happy it's a whole number this time. We're not that cruel usually. Usually in this graphing one, we make the numbers nicer. We might make you complete the square in another one that has fractions or decimals, but when it comes time to graph, we're like, let's just make the numbers nice, make sure we can do this, okay? So what do I do with that magic number? Yeah, we need the 25. That's what's magic about it. The 25, and I'm going to explain the magic here in just a second and demagicify it a little bit. But I want to add 25. 25 is the number I really want there. I'm not allowed to do that. That would change what the equation's worth. But I can do it as long as I go add 25 and then subtract 25. It's a little mathematical trickery to get the 25 I need. Because this now is a nice, easy trinomial. Two numbers that multiply to 25, but add to 10. 5, he says 5. He didn't say 5 and something. He said 5. It's 5. That's what completing the square is all about. It's going to be x plus 5 and then another x plus 5. The 25 was the perfect number that turned this into a square. And that's why it's called complete the square. I've completed it. So this becomes this. And I encourage you to underline that to remind yourself that what's there, x squared plus 10x plus 25, is all in the brackets, x plus 5 squared. It's all there. The 10x is not gone. It's in the brackets. If I expanded that out, I get it back. The 25 is not gone. It's in the brackets. And it's all multiplied by that negative out there. There, it's all good. And the step that most people forget, multiply that negative or the 2, or the 7, or the 4, whatever's out there gets multiplied by that other part of the magic number. And that's what finishes off complete the square. Most grade 10s think complete the square is the most awkward bit of algebra they ever learn. And that's okay, but it's very repetitive. I must tell you, it's the same steps every time. Factor, add and subtract the magic number, multiply it back out. Yes, those are the steps. I'm not claiming that's easy. I'm just saying it's very, very, very repetitive. So if you practice it, you should be able to get through it okay. Yeah. Especially on the culminating. The culminating, you can have this example and the previous one, just look and go, okay, what were the steps here? What did he do there? Just make sure you're looking over tonight. Don't figure it out during the culminating on Thursday. Figure it out tonight. Today, look it over and go, yes, I get that. So on the culminating, you're like, yep, boom, done. So that open book doesn't become open disaster. Or what was it? We had a saying yesterday. Someone said, open book, no. It was Austin, wasn't it? I think so. Once you start flipping, your mark starts dipping. It's a good saying. I don't want that to scare you. And if you start flipping, you're like, oh, this is when it goes wrong. No, no. If you're flipping to go, where's that example? Oh, there, good. Yeah, double check that's right. Yeah, but if you're just flipping going, looking for one that's like the one, I hope it's in here somewhere, that's when you know trouble has started, yes? And why open book can be a little dangerous. Anyhow, once it's in vertex form, happiness returns to the kingdom. Because you're like, oh, I can do this now. I can easily get the vertex. And where were we at? Do we call it the graphing rule? Do we call it the step pattern? What do we call it? The 1A, 3A, 5A thing? Step pattern? We were calling it step pattern? Yeah. Sorry, other years I've called it the graphing rule. Step pattern is better. I'm glad I used that. Okay, who's on the case here? Vertex? I'm going to act like she's wrong, okay? Just to rock your world and try and imprint it in your memory. -5? That says +5. Where are you getting -5 from? She knows. She points at her brain like, I know. The 1 inside the bracket does the opposite of what we think it does for some reason. We did talk about the possibilities of why that's true, but it's just the way it works out. That 1 in the bracket goes left 5 over to -5. How about the step pattern? What is the step pattern always? 1A, yeah. And I know why you said 1, 3, 5, because when I first taught it, I said, oh, it's 1, 3, 5. And I admitted right at the time, I'm lying a little bit. It's 1A, 3A, 5A. So you got to multiply that step pattern by whatever's out front here. So it's -1, -3, -5. With that, parabolas are almost as easy to graph as lines. You've got the starting value, and you got where to go, which is what lines were. So -5, 12. And if on a CCA or a test, the grid paper provided your point isn't on the grid paper, it might be time to panic a little bit. Chances are we thought it out and gave you good grid paper. Now, does that mean that you just give up on the question? No, you say, hey, Mr. Todd, can I have a piece of graph paper? Obviously, I've made a little mistake here, but I want to show you my work. I want to get 5 out of 6 on this, or 3 out of 4 on this, whatever my little mistake is, because I can't find it. And then you just graph on a separate piece of graph paper, and you get most of the marks. So we don't panic in situations like that. We just go, clearly there's something little gone wrong here. And then from there, we go over 1, down 1. And from there, over 1, down 3. And from there, over 1, down 2, 4, 5. Ooh, what's the next one? I've got room here maybe. 7, so that's down to here. So it's truly a step pattern. It tells you what steps to take. Yes? Let me say it again. On the other side. From this point, over 1, down 1. From that point, over 1, down 3. And from that point, over 1, down 5. It happens to hit the edge of my paper here. So I'm just showing that much of the parabola. Should put arrows on the ends, friends, to say I know it goes on from there. But that's all I'm going to show you, because that's all the graph paper I've got. So the blank, what is this? The blank value of y is blank when x equals blank. What are they referring to here? Max, the maximum value of y is 12 when x equals negative 5. Could you have known it was going to be a maximum before you even started the question? Yeah, because it was opening, the negative said opening downwards. So I knew I was going to eventually end up with a maximum. That's just an extra little piece of information there. But you tell me your questions. That's one of the big two reasons why we complete the square. When you first learn complete the square, you're doing your homework, you're like, why are you torturing me with this? This is a crazy procedure. This is why. The payoff of complete the square is how nice it is to graph and how nice it is to see the maximums and the minimums. Okay. Which led to word problems, which I know was your favorite of the whole year. But do you have any questions on that before I move on? I hope you took good notes for your CCA. It's a good reference. Yes? That one had a negative, not a number out there, but there's examples from the previous day that had, like this one here, that one's a really good one to show numbers in there as well. Yeah? Okay, so what that led to was this. In fact, actually we did it in the reverse order. We got all this, the groundwork for this laid first, and then we went back and learned to complete the square. But here's why we're doing all these things. It says, describe in words how to transform y equals x squared to produce each of these functions. So, y equals x squared. If you had y equals x squared, how many things get done to it here? 3. I like putting little dots before I even start. Little point form dots like 1, 2, 3. I've got to describe 3 things that are going to happen to y equals x squared with these transformations. Invert on the x-axis. Maybe you called that vertical reflection. If he's using words that are unfamiliar, they're great words, but maybe you've been calling it vertical reflection, and that's fine too. That's the first thing that's happening. That comes from the negative up front. 3 units left. So that's a horizontal translation. 3 units left. Lots of this coming in grade 11 and 12, by the way. I just did this. We learned a new crazy function in advanced functions, the grade 12 course. And then we did these exact transformations. You would have followed the second half of the lesson. You would have had all you needed. You would have went, oh, left, 3, just like ours. Yeah? Oh, vertical reflection, just like ours. So we do a lot of this stuff coming up. And what's the last thing? Vertical translation. Down 5 units. All right. How many transformations does B have? 2. Which one would you like to talk about first? Yeah, vertical compression. Factor 0.7. How did you know it was a compression? What was it about the number that told you it was compression? Yeah, less than 1. Right, less than 1. So it makes it smaller. When you multiply by things that are less than 1, you get smaller numbers. And then the plus 2 outside, that's the one most people find easy. It's the one that's most sensible. The least thinking, the plus 2 out there is vertical translation. Up 2. Is this all ringing a bell? I must tell you, if quadratics is scaring you a little bit going into Thursday, most of quadratics went very well for us. Like really, really well for us. I'll look it back over, but maybe take some of the intimidation out and go, yes, complete the square is a problem, and yes, word problems were a problem. But the rest of it was all pretty nice. Stuff like this went very, very well. The tests were excellent. The scores were good. So let's not get overly intimidated by all this. Yes? Work on complete the square, look over some word problems, and then settle down. 2 transformations here. What does the 3 up front do? Yeah, vertical stretch. Factor 3, and how about -3 inside the bracket? Yeah, I'll use the fancy words. Horizontal translation right 3. I don't think anything's missed there. With 3 short examples, we covered all the things that could happen. Left, right, up, down, stretch, compress, reflection. Good reference sheet. Yes, for both the CCA and for studying for the exam. Everything's there. Yeah? We sat down and thought it out carefully to make sure our examples covered everything that can happen. So, for each of the quadratics above, state the vertex, direction of opening, max or min value of x. I'll do the first one, and then you try the next 2. Okay? Actually, I see some people have already filled in. If we are going left 3 and down 5, our vertex now is at -3, comma, -5. Direction of opening, if it's got a negative out front, it's been vertically reflected, so it's opening down. Max or min value of x. Oops. Max or min value of y. That's our fault. We retyped all this stuff to fix up the fonts and make it all beautiful for you. A little oops there. Max or min value of y is the -5. And when does that occur? At -3. Yes, those are just the word version of the vertex. Well, you try the other 2 real quick. See if you can do the other ones, which might be harder because they're easier in a weird sense. You might have to think just a little bit on those. We'll take them up in just a second. Yo! Yeah! How'd it go? There's another correction to be made. Did you catch it? I only caught it here at the end. When does the max or min value occur? X value of the vertex. So sorry, in an effort to make this beautiful, we rushed it a little bit. A couple little oopsies in there. No, there's no O's or K's. It's X's and Y's. Why do you make those stupid jokes, Mr. Todd? Why? All right, focus. Mr. Todd, can we do some word problems? Yeah, let's do some word problems. But let's again categorize word problems, shall we? I'm with you. I'm not against you. Word problems in quadratics can be tough. But not when they give you the equation. Yeah, if they give you the equation, you just have to read the question and decide what it is you have to do here. So let's go. The height of a flare, we do a lot of problems in grade 10 about the height of something that's flying through the air. This is a flare. Above the ground is a function of the time it is in the air. An equation representing the height of the flare in meters from the release position after t seconds is h equals negative 5t squared plus 100t. I must tell you, this is pretty close to the actual equation of things flying through the air. Negative 5 on the Earth, that would be like more like a negative negative 0.8 on like the moon. That changes depending on what planet you're on. Things fly easier on the planet. What's that? He's so right. Yeah. And this 100 is the initial velocity. Yes? So you physics people are about to find out this is right on exactly what the equation does. Anyways, what is the height of the flare after 3 seconds? Here, let's get ready for some physics here, shall we? This will really help. Even if you're not taking physics. Write down what they gave you in terms of the variable. They gave us 3 seconds. Is that the time or the height? Time. This really helps. It's just a simple little move, but it really helps to go t equals 3. Because then your brain comes online and goes, oh, I know what to do then. If I know t equals 3, what am I going to do with it? Yes. Sub it in. Yeah, I'm going to sub. He's right. We're going to multiply once we sub it in. So, therefore, h equals negative 5, 3 squared plus 100 times 3, negative 45 plus 300. H equals 255. Wow. That is up there. Did anyone punch in their calculator? Double check Mr. Todd's math on a... What day of the week is this?
Monday, Tuesday.
Monday, Tuesday. It's Monday, Tuesday. Welcome to Monday, Tuesday.
Tuesday.
Tuesday. What else should you do, friends? Therefore, the height is 255 feet after 3 seconds. It's meters, not feet. A couple of people on the one test. Randomly, like on the meters question, they wrote feet. On the feet question, they wrote meters. I don't know whether they were making fun of NASA or what was going on there. You just got to read the question. Yeah, know what you're working in. What is the maximum height reached by the flare? Okay, this is different. Here they gave you the time. Here they said the word maximum. Now, let's let that bounce around for a minute. If we want the maximum of a parabola, what feature of the parabola are we looking for? The vertex. If we want the vertex, what form? Vertex form. How do we get to vertex form? Complete the square. Do you see why that's so difficult? There's a lot of steps to the thinking. It's not just like bang. Max leads you to go vertex. Vertex leads me to go vertex form, and vertex form makes me say complete the square. Can that all happen quicker than that? Well, yeah, but that's all the details you got to know. So here I go. B. I think I left some extra space. I don't know if you have extra. Do you have lots of space? Yeah. Oh, you got a whole page. I think I left an extra page for me, so I think I can do B over here. You don't care. All right. Here's the whole procedure again, friends. Common factor out that A value. Negative 5 t squared 100 divided by negative 5. Beep. Negative 20t. That was step 1. Step 2. Magic time. Yeah, do the thing with the thing. B over a 2 squared. So it's negative 20 over 2 squared. Negative 20 over 2 is 10 squared. 100. Magic number is 100. Why is it magic? Who? Let's see if someone can tell us why it's magic. It's such a good number. H equals negative 5 t squared minus 20t plus 100. There, I needed 100 in there. You can just add 100 to every equation. I also have to minus 100. It's a little math trickery. I need 100, so I add 100, and then I subtract 100. Why is that so magical? What happens now? Now we what? Now we do stuff. Which stuff are we going to do? Factor that little trinomial I've created. And what two numbers multiply to 100 and add to negative 20? 10. 10, 2 times. Yeah, negative 10, yes. So, I like underlining both those. So you know, okay, that's all taken care of. Those 3 terms are all in there. That's all taken care of. And then don't forget, beep. I am ready to make my concluding statement.
I'm running on more than empty.
This arrow helps. Put that arrow in there to remind you. Yes, as long as the question doesn't say complete the square. And I think actually on the CCA, you're reading our minds. There's one question where you say either do it this way or this way. So you've got your choice. I'm doing a complete the square here because I was worried some people were having trouble with complete the square versus that procedure, which a lot of people seem to get. But you're allowed to do either one. Unless it tells you, unless it says please complete the square, then you're stuck with this method. So don't just go, oh, I don't have to learn this at all. Yeah, there's the vertex. Is 10 comma 500, and from that can you then get the max height? Yeah. Therefore, the max height is 500 miles. Meters. The max height is 500 pounds. No one would write 500 pounds. Well, you wrote feet when it said meters, so I don't know what to expect now. I understand. You're reading one question, doing this one. I get it. But please take a look. As you're walking in to hand in things, flip through to check all the units. That's a good way. And flip through to find therefore statements. I don't know how many therefore statements have been written on my desk before. Someone's about to hand something in like, oh, therefore, max height, 500 meters. There. Ooh, ha, done. Yes? Like it. Question? You don't get the CCAs back, you get the marks back. You can come and look at them, but they're not something that they're really part of the exam procedure. So you can come look at them, but you don't actually get them back. No. I will get them marked before you go to do your exam. So let's say you get 90 on all of them. You're like, oh, life is good. Yes? Let's say you get 50 on trig and 90 on the other two. You're like, I got to see that. I got to know what's going on so I can do more prep for trig for the exam. See, it's in grade 10 we try to help you a little bit. It's almost like extra exam review that's worth marks, these CCAs. Because folks, it's really not that much. 10% for 3 parts. You know, like it's not, your whole life's not at stake here, yes? We've tried to lower the temperature here a little bit. I almost jumped ahead. C. Very tough question. It says, determine the time the flare is above 80 meters. Okay, physics people, here we go. The 80 meters, is it a time or is it a height? We seek. Ooh, fancy math sentence here. We seek h equals 80 meters. These kind of statements, physics and chemistry people, really help your brain. Write down what you were given, because then your brain might trigger and go, oh, I need h equals 80 meters. Where would you sub it in? Would you sub it in as t? No, as a h, okay? That's step 1. So 80 equals negative 5t squared plus 100t. So maybe that's not too tough to know where to sub it. But now we got problems, friends. Now what do we do? Look at me. Took my watch off, put my pointer down, fixed my hair. Yes, this is the fixed version of my hair. She's got her hand up. Move the 80 over. No matter what we're going to do next, we need 0 on one side. That's different than linear. Linear was isolate t. I can't isolate t. There's multiple t's there. So our strategies all are based on getting 0 on one side. Then, does it factor? Does it factor? Okay, so we'll try to factor it. What's the first step of factoring? Take the -5. We're praying. Come on, come on, come on. No, we're not praying. Who's standing up on the bench going, don't worry, I got it. You don't got it, I got it. What's the other thing? If this doesn't factor, who's jumping in? Yeah, the quadratic formula is like, I got it. Why don't you just do the quadratic formula if you're worried about it? Because that's true. But let's just check what factors. -5 t squared minus 20t plus 16. I'm still not convinced of factors. What two numbers multiply to 16 but add to -20? 1 and 16? No. 2 and 8? No. 3 and 5? No. 4 and 4? No. She no factor. She no factor. But we made a good attempt at it. Now quadratic formula. I got news for you. You can quadratic formula this and get the right answers. You can quadratic formula this and you'll get the same answers. It reminds me of rise over run, where it's like, oh, what if I do these 2 points? It'll reduce down to the same answers. Math will not be broken. So if you do common factor like this and you get this, I encourage you to use the smaller numbers. Why wouldn't you use the smaller numbers? So my A is 1. My B is -20. And my C is 16. If you really want to understand what happens, if I get a fraction answer here, say I get 2/3. If someone used these numbers, they would have got -10 over -15, and they would have reduced it to 2/3. So you'll get the same answers, regardless. Okay, do I remember this thing? T equals -b plus or minus square root b squared minus 4ac over 2a. Your physics teacher, your chemistry teacher, your grade 11 teachers, all going to presume you know this. Some of them don't know that in grade 10 we're sort of kind, and we put it on the exam for you, on the test for you. I don't know if we should or not, but we do. So get ready when you get to those classes, like, yep, quadratic formula, and you're like, do we get the quadratic formula? And they'll look at you like, no, you don't get the quadratic formula. Like, okay, no problem. I'm in grade 11. I'll memorize it. It's okay. Yeah? So just be prepared for that. T equals -20 plus or minus square root -20 squared minus 4 times 1 times 16 all over 2 times 1. Geez, I did that fast. I better check to make sure I sub those in right. -b plus or minus b squared minus 4ac all over 2. Yep, things look good. T equals 20 plus or minus square root e 336. I did that in my head. I got to check. 400 minus 64. 336? Anybody on the calculator? GG? 336? What a mess. What a mess. So I get two different ones. T equals 20 plus root 336 over 2, or T equals 20 minus root 336 over 2, both of which can be typed into your calculator. You should try that now to make sure you know how to type it into your calculator for Thursday. I'll get mine out. What's that? You like 464? Here? Try again. -20, all brackets squared, minus 4 times 1 times 16. I think maybe you did plus. Let me know. If we're wrong, we want to fix it. Is it good? So after it's all done, I get 19.2. You try it. Make sure you get the same as me. Don't let me away with it. Plus, I want to check for my video and make sure the video's all right. And the other one I get is 0.83. Did you get the same?
I agree.
He agrees. What's that? 20 minus root 336 over 2. Try it again.
In degree mode?
Oh, that's good. That's good. Degree only. I messed up my 11s the other day. I'm like, make sure you're in degree mode. And they're like, really? I'm like, no, it's not sine, cos, or tan. You don't need to worry about that.
It only matters if you're doing those things?
Yeah, it only matters if you're doing sine, cos, or tan. Question? The only time you care whether it's in degree mode or not is if you're doing sine, cos, or tan. If you don't press the button sine, cos, tan, you don't care. Because remember, we didn't care until a few weeks ago. Yeah? So you don't have to worry about it unless you go press the sine, cos, or tan button. For grade 10s, though, degrees is the safe place to be. Nothing can go wrong if you're in degrees. Is there something other than degrees? Coming soon to a math class near you. Did I answer the question, though? That's a good thing to, as you're about to hand it in, let's just make sure I answered these questions. It says, determine the time the flare is above 80 meters. The flare is above 80 meters between t equals 0.83 and t equals 19.2. Here's a little picture, a little tiny picture. See? It's above that height for a little bit of time there. But tell me your questions, friends. Look, quadratic formula reviewed on your CCA. Aren't you happy? You are so happy. Whew. Are we done? Oh, good. One more, a word problem with no equation. Hopefully the geometry one is one that you're like, okay, well, there was a crazy profit thing. I don't want to talk about that. But geometry, not bad. A rectangular field bounded on one side by a lake. All right. Lake coming up. I got blue. Maybe you'd like to draw a little wavy line. It's bounded on 3 sides by an 800-meter fence. I'm going to do this question 2 different ways. The way I taught and the way some people like. Okay? The way I taught looks like this. I said, okay, well, if I've got 800 meters of fence and I make this x, then this one over here also has to be x. You could make it y, and I'm going to do that in a second. Some people will like that better. If you don't like what I'm doing here, I'm going to draw a line, and I'm going to do it a different way. So what I'm going to do in mine is I go, well, okay, if that's x and that's x, how much fence do I have left for the last 3 sides? I had 800. I used up x. I used up another x. 800 minus 2x on this side. That move avoids using y. I do not claim it's better. It's a choice I made of how to teach this. Yusuf says, well, what if I make that y? Then you need a little more work on perimeter. Then you go, okay, that means that these 3 sides, the x, the y, and the x, all have to add up to 800. So he says 2x plus y equals 800. Then if he wants to figure out what y is, he'll move the text 2x over, and he'll get 800 minus 2x. I like that too, and I actually, even though I didn't teach that in class, I saw people doing that on that test. So maybe that's the way you want to do it. So you can handle that either way. You can just use your brain to go, well, what would the third side be? Or you can use a little bit of algebra there. Either way, I'm ready to build an equation for area. How do we find area of a rectangle? Base times height, length times width, whichever version of that you want. I'm going to write length times width, but if you write base times height, that's totally cool. And so here, my length is x, my width is y, or I'm going x times 800 minus 2x, because that's way better for what we're going to do, because it's only got x's in it now. I'm actually going to draw a line to that going, now I've got the equation. For those of you that are like, if you just give me the equation, I'll be okay. Okay, at that point in the question, now you've got the equation. There's two ways to proceed now. We've given you two options. I could complete the square to find the vertex, or I could do the other method we had, which was to find the zeros and go halfway between them. Which one looks like it'll be easier? Yeah, because this is already factored. Already factored, maybe complete the square is not the way to go. I'm not putting down complete the square. Complete the square is a very powerful method, and I've done a word problem with complete the square right there. So you've got complete the square in your notes. The other way to handle this, and do it whichever way, I won't mark it wrong, is to go, well, when does a equal 0? X equals 0, or 800 minus 2x equals 0. Couple of steps later, I get x equals 400. That's when the area will be 0. So where is the vertex? Hint coming. How do I get the x value of the vertex now that I've got those two symmetrical points? Add them and divide by 2. Now, by the way, you can complete the square. If these steps are like, ooh, I don't know. And I'll do complete the square. To finish off this lesson, on the next page, I'll do complete the square for anyone who thinks that that's better for them. I go 0 plus 400 over 2. So the x value of the vertex is 200. And I'm actually done. Therefore, the length should be 200. Oh, how do I get the width now? I decided this should be 200. And that's 200. So it's 400. Yeah, so you go, and width equals 800 minus 2 of the 200s, which is 400. Is it proper form to be doing calculations in your therefore statement? Well, no, but it's good learning and teaching in grade 10. So we sort of let you away with stuff like that as you think it through, okay? I don't like those steps. Don't scare me. I want to complete the square. I'm like, yeah, just a second.
I feel like there's a shortcut here because, like, for all these questions, we have to get the maximum area. The y side is just half the total, and the other two sides are just half the symmetric.
He's seeing some shortcuts here with rectangles. And I must tell you,
No shortcut for other shapes.
yeah, we don't care about rectangles really. Here's where we're going. We're practicing the algebra here so that I can go after this shape and minimize the surface area for a given volume. So I can make the perfect Pepsi can that uses the least amount of, and then suddenly the patterns and so on. And sometimes there's a top on it, and sometimes there's not an open top on it, and the patterns become too much. But you're right. If our whole life was rectangles, we probably would just go, oh, it's always, well, I'll give it away. In rectangles, use the same amount of lengths as you do widths. 400 and 400. That's when you'll see them. And so when it's a 4-sided rectangle, square. 2-sided rectangle, square. 3-sided, these two add up to that one. So that's the end of rectangles if we wanted it to be. We're using it to practice the algebra. So that when things get tougher, we're ready. Yeah, good question. Oh, but I promised to do that with complete the square. Where was I? those of you who don't like what happened there, you'll transport from here over to here. A equals, I forget already, x times 800 minus 2x. Complete the square, people. We'll multiply out the brackets. You'll rewrite it in standard form. That is, with the x squared term first. And then here comes complete the square one last time in this lesson. Common factor out the negative 2. Get your magic number. B over 2 squared, which is negative 400 over 2 squared, which is negative 200 squared, for 40,000. Area equals negative 2 x squared minus 400x plus 40,000 minus 40,000. Factor those. Two numbers that multiply to 40,000 and add to negative 400. Where is the number? You don't need to figure out the number. It's on the page. It's right there. We found that number in the middle of all this. So I get A equals negative 2 x minus 200 all squared plus the 80,000 from multiplying that out. Therefore, x equals 200, the x value of the vertex. And I'm back to where I was with the other question. I don't care which way you do. It could have gone both ways. It could have been, oh, I like this better. It could have been like, no, I don't like this better. And then I looked at this and went, wait a minute. Well, I don't like that better. Maybe I do like this better. Or maybe you're like, no, no. Now that I know how to complete the square, I'm just going to complete the square every time when these situations happen. I find that easiest to think it through. Do you have questions about that? I did that last one a little bit fast. So I paused for questions.